So, you've made it to bedtime, or maybe you're walking through a forest at dusk with headphones in, trying not to think about the fact that humans don't actually know everything. Either way, you're here now, and I have a question for you. What if we weren't the first? Not the first species to invent tools or language, not even the first to build cities or burn coal. What if we weren't the first civilization? There's a theory. It started as a thought experiment, but it refuses to go away. It whispers like wind through stone ruins. It's called the Silurian Hypothesis, named after a fictional race of intelligent reptiles from an old British science fiction series, Doctor Who. The idea is simple enough to be dismissed, and just complex enough to keep scientists awake at night. If a technologically advanced civilization had existed on Earth millions of years ago, could we even tell? That's the unsettling part. Because the answer might be no. Tonight, we're going to dig, gently, through deep time. We're going to trace the barely there outlines of vanished possibilities, listen to ancient silences, and let the sediment of the Earth tell its half-buried secrets. And if, at some point along the way, you start to wonder whether this has all happened before, don't worry, you wouldn't be the first. So before you get too comfortable, take a moment to like the video and subscribe, but only if you really like what I'm doing here. And tell me, where in the world are you, and what time is it right now? Because wherever you are, it's a good night to unlearn what you thought you knew. The story begins not with humanity, but with something older, something deeper. A question whispered through limestone and granite. A footprint, not in sand, but in stone. You see, humans have been around for about 300,000 years, depending on how you define us. That's nothing. It's a spark, a blink. The Earth is 4.5 billion years old. Multicellular life? Over 600 million. Dinosaurs came and went, rising and falling across nearly 200 million years. Civilizations have risen and fallen before, but not like ours. Ours is loud. It glows at night. It drills, smelts, plasticizes, and radiates. It leaves things behind. But for how long? The idea that other intelligent species may have emerged long before us is often dismissed as pseudoscience or fantasy. And maybe that's fair. But every so often, real science asks unsettling questions. In 2018, NASA climate scientist Gavin Schmidt and astrophysicist Adam Frank published a paper that asked exactly this. If an advanced industrial civilization had existed before humans, what traces would it leave? They weren't saying it did happen, just asking, would we even know? To answer that, you have to think like a geologist, or perhaps more accurately, like time itself. Geologic time doesn't work like history books or timelines. It isn't measured in centuries, but in eras, epochs, mass extinctions, continental drift. Tectonic plates crush the past beneath them. Fossils, even the best preserved, are rare. Only a tiny fraction of life ever becomes fossilized, and even less survives the churn of the Earth. Imagine New York City. Now imagine it flattened, buried under lava or ocean sediment, left undisturbed for 50 million years. Then imagine someone, something, digging there. What would they find? Probably not the Statue of Liberty. Maybe not even bones. Maybe just some strange minerals or layers of carbon, or chemical traces from long-degraded plastics. It's hard to wrap the human mind around this. But Earth has destroyed entire worlds before. Continents have been obliterated. Oceans have vanished. Species have come and gone, leaving barely a whisper. Here's a strange but true fact. 99.9% of all species that have ever lived are extinct. And yet we often act like we are the final draft of evolution. The last word. The pinnacle. The Earth might disagree. One of the things Schmidt and Frank focused on was the Anthropocene, a proposed epoch we're entering right now, marked by human industrial activity. Its signals in the rock record will include plastics, fertilizers, carbon isotopes, and the mass extinction we're currently helping along. These might persist for millions of years, or they might vanish, slowly ground down and weathered by time. That's the problem. Even when we know what to look for, time is ruthless. It folds evidence away, bakes it, recycles it. Historians are still debating whether geological processes could fully erase the signature of an ancient civilization that was as advanced, or more advanced, than our own. The answer seems to be maybe. Now let's turn our eyes toward a curious little object. the London hammer. Supposedly discovered in Texas in the 1930s, this hammer appeared to be embedded in rock that some claim to be 100 million years old. Of course, the scientific consensus is far less mysterious. It's likely a 19th century hammer around which the concretion formed naturally. But even so, its legend lingers, and it's not the only so-called out-of-place artifact. From mysterious metal spheres in South Africa to supposed human footprints next to dinosaur tracks in Paluxy River, these curiosities pop up like weeds in the tidy garden of scientific consensus. Are they hoaxes? Misunderstandings? Probably. But they tap into something deeper, a suspicion that the past isn't quite as straightforward as we pretend. Here's something else to keep you up at night. In the entire geologic column, spanning hundreds of millions of years, only a few layers contain detailed fossils of soft-bodied creatures. Most things don't fossilize at all. Not skin, not eyes, not hair or fabric. If an ancient civilization wore woven cloth or used wooden tools, it's gone. Gone without a trace. Oddly enough, peat bogs might preserve a human for thousands of years, but the ocean, floor erases everything. We think of ourselves as lasting, permanent, but our own cities are already falling apart. Within a few centuries of abandonment, nature reclaims them. Iron rusts, concrete cracks, asphalt turns to dust. Within 10,000 years, forests cover everything. Within 1,000,000, no one would even know we were here, except maybe for the chemicals. That's why this journey isn't about conspiracy theories. It's about humility, about letting go of the belief that we'd know if someone came before us. Because maybe we wouldn't. And here's a final curious detail. In ancient Mesopotamian records, the Sumerian kings list includes rulers said to have reigned for tens of thousands of years before the flood. Scholars interpret this as myth or exaggerated memory. But what if it's not entirely invented? What if it's a dim echo, a cultural scar, something passed down and mutated like a dream? That's the kind of question that won't let go. So tonight, as you lie down and drift off, I invite you to follow that dream. Follow it through layers of stone and myth, through epochs of silence, through questions with no answers and answers with no questions. Because deep time holds secrets. And sometimes, the absence of evidence is not the evidence of absence. Close your eyes for a moment. Imagine a map of the Earth, not the modern one, with lines and flags and cities that shine at night, but a map that shifts and groans with time, a map without borders, just land masses drifting like lily pads on molten water, breaking apart and crashing back together over hundreds of millions of years. Now picture yourself trying to leave a message on that kind of planet, something that might last 100 million years, something that whispers, "We were here." Not so easy, is it? One of the most sobering truths about our planet is that it forgets. It forgets with a grace and patience that makes even the oldest human monuments seem like candlelight in the wind. Earth is constantly changing its face, and it rarely leaves keepsakes. You may have heard the term deep time, a scale of years so vast it defies personal comprehension. To grasp the full weight of the Silurian Hypothesis, you have to breathe in that concept. You have to accept that we live atop a surface that has been erased and rewritten, over and over, like an ancient scroll that's been scraped clean to make room for a new story. Let's consider a single stretch of time, 100 million years, not a random number. It's long enough that any surface features, roads, buildings, cities, even entire continents, can be rearranged or consumed by the planet's tectonic ballet. The ocean floor, for example, is rarely older than 200 million years. That's because it's born at mid-ocean ridges and destroyed in subduction zones. It's recycled, ground into magma. So even if someone had carved a message on the seafloor during the time of the dinosaurs, it would be long gone, now melted into the planet's crust and reborn as something new. You might think, well, what about land? Continental crust is older, right? And yes, some of it is ancient. There are parts of Canada, Australia and Greenland that are over 3 billion years old. But those rocks are exceptions. Most of what we walk on is much younger, and even the oldest crust is not immune to erosion. Wind, rain, glaciers and vegetation wear everything down. Mountains rise and fall, valleys fill and drain, volcanoes erupt, burying everything beneath. And in the slow churn of time, entire geologic records can be folded, faulted, and buried so deeply they become something else. Historians are still debating whether civilizations like ours, defined by industry and large-scale energy use, could leave behind evidence that persists for tens of millions of years. Even if such traces exist, they might be buried in places no human has ever drilled. Or worse, they might be misinterpreted as natural events. After all, we already have examples of sudden global warming in the rock record. We already have carbon spikes, mass extinctions, and mysterious geochemical changes. Could some of those be fingerprints, mistaken for background noise? Let's look at something called the Paleocene-Eocene Thermal Maximum, or PTM for short. It happened about 56 million years ago. During this event, global temperatures soared, carbon dioxide levels spiked, and ocean chemistry shifted dramatically. The cause? Scientists point to volcanic activity, methane clathrate releases, or even a comet impact. But it's a strange, abrupt signal, like someone flicked a switch. Some researchers have quietly wondered, could something artificial explain it? Not likely, they say, but not impossible. Now imagine this. A civilization that rose and fell 100 million years ago. Maybe they weren't human. Maybe they looked nothing like us. But they mined, built, burned fossil fuels and altered their climate. Maybe they even knew they were doing it. But then they vanished, collapsed, or transcended. And all that remained was a chemical ghost, a faint anomaly in the carbon isotope record. If you went looking for their ruins, you'd find nothing, or almost nothing. And that's the hardest part of the Silurian hypothesis to accept. The Earth is too good at hiding her scars. Here's a peculiar historical fact. The oldest currently known structure made by humans is the Göbekli Tepe site in Turkey. It's around 11,000 years old, give or take. That's before writing, before farming, before metal tools. Just pillars and carvings arranged in ways that suggest meaning, ritual, and complexity. Now think about this. That's only 0.001% of Earth's history. Less than a flicker. And yet even that site was almost lost to time, buried under sediment until rediscovered by accident. Now scale that up. What if a civilization had existed not 11,000 years ago, but 110 million? Do you see the problem? There's a reason archaeologists dig with brushes and not shovels. The past is fragile, and the farther back you go, the more it disappears. Even bones vanish. Even stone is not forever. One odd little fact. There's a place in Africa called the Erasure structure, also known as the Eye of the Sahara. From space it looks like a massive, perfectly round bullseye. Geologists say it's a natural formation, shaped by erosion and uplift. But others have speculated wildly. Atlantis, lost cities, alien outposts. While mainstream science leans toward geology, it still leaves a trace of wonder. Because things in nature don't always behave predictably, and sometimes the Earth mimics design. Let's take it further. Think about the Grand Canyon, a magnificent cut through millions of years of rock. Each layer tells a story. Some layers are thick with fossils, others nearly empty. It's not a complete record. It's a jigsaw puzzle with most of the pieces missing. But imagine if somewhere in those layers there was a sliver of concrete, a vein of rebar, a trace of titanium alloy. Would we recognize it? Would we believe it? Maybe, maybe not. Because here's the truth. Our understanding of deep time is limited by our own short lives. Our curiosity only reaches as deep as our tools allow, and sometimes those tools aren't looking for what doesn't fit. That's why the Silurian hypothesis matters, not because it suggests dinosaurs built cities, but because it reminds us how little we know about the deep, silent epochs of Earth's past. You might be wondering, why Silurian? The name is borrowed from Doctor Who, of course. The fictional Silurians were intelligent reptiles that ruled Earth before humans, but in geology, the Silurian period was a real era, about 443 to 419 million years ago, long before mammals, before dinosaurs, just ancient seas, early land plants and trilobites crawling the seafloor. If a civilization had existed then, it would be unrecognizable. The continents were in different places. The air was different. The sky had no birdsong, just wind. And yet, isn't that the point? Civilizations might not need to look like ours. They might not leave pyramids. They might leave something subtler, something stranger. And the Earth, our forgetful Earth, might swallow those signs, layer by layer, until only the faintest echoes remain. So next time you walk along a rocky cliff, or stare into a canyon, or pick up a stone smoothed by ancient water, ask yourself, what don't I see? Because sometimes the scariest stories aren't the ones we tell, they're the ones we forget. Down in the dark layers of earth, buried beneath forests, deserts, and oceans, lie the memories of life long gone. Skeletons curled in silence, shells crushed under pressure, seeds fossilized mid-sprout. But for every fossil we find, for every dinosaur footprint or ancient fern frond pressed into shale, there are countless more we never will. Because most of the past doesn't fossilize at all, most of it vanishes. So what does that mean if you're looking for a lost civilization? If you're listening closely tonight, this is where the story gets quieter, softer, and stranger. Fossils don't lie, but they also don't say everything. They whisper, and sometimes they leave just enough silence between their words to let your imagination in. The fossil record is not a museum. It's a shattered manuscript. A few scattered pages survive, some in the wrong order, others crumpled beyond recognition. The vast majority of living organisms decay without a trace. Even bones, even teeth, even shells. Most are claimed by time. Fossilization requires rare and perfect conditions, rapid burial, mineral-rich waters, protection from scavengers, pressure, and more time than the human mind can comfortably understand. And that's if you're lucky. Soft tissues almost never fossilize. Skin, organs, muscles, they vanish. Now imagine buildings, fabrics, wires, plastic, data stored magnetically, light bulbs, books, paper, all gone. Even stone tools wear down, even metal corrodes, and anything on the surface of the earth is at the mercy of erosion, weather, and tectonics. Historians are still debating whether the fossil record can truly be trusted as complete. Most agree that it gives us a blurry sketch, not a portrait. That's why even the most detailed reconstructions of prehistoric life are provisional, and that's part of what makes the Silurian hypothesis so unsettling. It reminds us that we may be missing more than we know. There's a term for the unevenness of fossil discoveries, taphonomic bias. It refers to the way different organisms and environments are more likely to produce fossils than others. Swamps are good. Deserts? Not so much. Creatures with hard parts, shells, bones, exoskeletons, fossilize more easily. Jellyfish, birds, primates, much harder. Civilization, in all its fragile complexity, is built mostly of things that rot. Now let's consider something eerie. There are entire ecosystems from Earth's past that we know almost nothing about. Gaps in the record. Ghost worlds, you might call them. Periods of time with hardly any fossils at all. Sometimes we find a sudden explosion of diversity, as in the Cambrian explosion around 540 million years ago. Other times we find sharp declines, as in mass extinction events. But between these dramatic moments, there are vast stretches where silence rules. No fossils, no footprints, just the stillness of stone. So what if a civilization had existed during one of those ghost periods? Would we even know? There's an odd little fact from the world of paleontology. The earliest known fossils of complex life were once mistaken for lichen or algae. But over time, and with new tools, scientists reclassified them as members of an entirely different kingdom. Enigmatic creatures with no modern analogues. The Ediacara and Biota, they're called. Their forms are so alien that they look like dreams pressed into rock. Some have radial symmetry, others resemble quilted pillows, and for decades their place in the tree of life was uncertain. Now imagine finding a fossilized fragment of an ancient tool, something not made by any animal we know, something manufactured, something impossible. How long would it take us to recognize it? A single artifact, out of context, degraded, deformed, might be dismissed as a curiosity, a mineral inclusion, a crystal formation, a trick of erosion. And yet, it could be the last whisper of a civilization erased by time. That's why scientists like Schmidt and Frank approach the Silurian hypothesis not by looking for fossils of cities or machines, but by considering broader signals, isotopic anomalies, global chemical changes, shifts in sediment composition. Fossils may be too rare, too silent, but still. Sometimes the rocks whisper. In 1992, paleontologists found fossilized dinosaur feathers in China. At first, no one believed them. Feathers didn't fossilize, people said. But there they were, etched in stone like delicate brushstrokes. It took new techniques, new technology, a new open-mindedness to recognize them. What else might we be missing, simply because we've told ourselves it can't be? Historians are still debating whether Homo sapiens even noticed the Neanderthals' full intelligence until long after they vanished. For decades, they were imagined as brutish cavemen. Now we know they buried their dead, made jewelry, and may have even painted cave walls. Their fossils were always there, but our understanding wasn't. Let's take a turn now, away from bones and towards something stranger. Have you ever heard of the blue glass desert of Libya? It's real. In a region of the Sahara, you'll find chunks of translucent yellow-green glass scattered across the sand. Some pieces are large, some are jewel-like, and for years scientists have debated what caused it. The current theory is that a meteor exploded in the atmosphere above the region, generating enough heat to fuse the desert sands. But for decades, people speculated about ancient weapons, long-lost technologies, or forgotten disasters. Even today, it doesn't quite sit right, because sometimes the evidence is there, but the story behind it is missing. Here's another peculiar example: the Moki marbles of Utah. These spherical stones look uncannily like manufactured ball bearings. They're not. They're iron oxide concretions, natural, formed over millions of years. But it took careful study to determine that, and for every known example of a natural phenomenon that looks artificial, it makes you wonder, how many artificial things have we mistaken for nature? That's the great challenge of reading fossils, or more accurately, reading into fossils. It requires humility, patience, imagination, because the Earth rarely hands us a finished novel. More, often, it gives us half a sentence in an unfamiliar language carved on crumbling paper. Even the best preserved fossils are mere shadows of what once was, and shadows are tricky things. So tonight, as you settle into the layers of your own mind, remember this. The fossil record is a story written by pressure and chance. Most pages are missing, some are unreadable, others have yet to be found, but they're out there. And sometimes, in the spaces between bones and silence, something unexpected waits. Some stories refuse to stay buried. No matter how thoroughly they're dismissed, no matter how tightly the lid of science is screwed down, a whisper escapes, a rumour, a photo passed from hand to hand, a rusted hammer encased in ancient stone. Yes, a hammer. In the 1930s in London, Texas, not England, as one might first assume, a couple walking along a limestone ledge reportedly found something peculiar. Lodged in a rock formation they believed to be over 100 million years old was the head, and part of the handle of what appeared to be an iron hammer. It looked ordinary, but it was in the wrong place. The stone, they claimed, had hardened around it. And so began the long, strange tale of the London hammer. To many it became an icon of out-of-place artifacts, OOPArts, as they're often called, objects that seem to exist outside the accepted timeline of human history. Creationists embraced it. Fringe theorists wove it into tales of lost civilizations. For them, it was proof that something was very wrong with our understanding of history. That either the Earth wasn't as old as science claimed, or that something intelligent walked it long before humans ever arrived. Mainstream science was, unsurprisingly, skeptical. Geologists pointed out that the limestone surrounding the hammer wasn't necessarily millions of years old. It could have been a concretion, a hard mass of mineral matter formed around a central object in just a few decades. This is known to happen, especially in areas rich with dissolved minerals and slow-moving water. As for the hammer itself, likely a 19th century miner's tool, the kind used in that very region during America's frontier expansion. Case closed, right? Well, maybe. But here's the thing, the hammer became a symbol, not necessarily of a hidden past, but of how we react when something doesn't fit. The truth is that out-of-place artifacts are scattered all over history like breadcrumbs. Some are hoaxes, some are misunderstandings, but a few remain unexplained. Take the Antikythera mechanism, discovered in a shipwreck off the coast of Greece in 1901. It's now understood to be an ancient Greek analog computer used to predict astronomical positions. But for decades, its complexity baffled scientists. Gears, dials, precision engineering, all from a time we thought such technology didn't exist. Or consider the Baghdad battery, a clay jar from ancient Mesopotamia with a copper, cylinder and iron rod inside. Some have speculated it was a primitive galvanic cell, a battery. Though that interpretation is controversial, and most scholars now lean toward it being a storage vessel, The possibility stirred imaginations. Historians are still debating whether these artifacts represent isolated strokes of genius or lost threads of technological continuity, brief advances erased by war, collapse, or forgetfulness. Which brings us back to the hammer. The deeper mystery isn't whether it's ancient, it's why we're so eager to explain it away, or explain it into something spectacular. Humans have a curious relationship with mystery. We're both drawn to it and terrified of it. When we find an object that doesn't fit our narrative, we have two choices: force it to fit, or throw it out. The Silurian Hypothesis invites us to do neither, to sit with the discomfort, to let the gaps remain. Because if there had been a civilization millions of years ago, it's unlikely we'd find something as obvious as a hammer. More likely, we'd see traces in the geochemical record, odd isotopic signatures, sudden spikes in heavy metals, unusual concentrations of carbon, or synthetic compounds that nature doesn't create. But if, just if, one object slipped through time, what would it look like? It probably wouldn't be whole. It might be melted, corroded, fused with stone, its purpose obscured. It might not even be recognizable as artificial. Imagine future scientists finding a USB drive, not knowing what it is, thinking it was a tooth, or a seed, or an oddly shaped stone, and who knows, maybe we've already misclassified something like that. One strange fact: in the 1990s, researchers in the Ural Mountains discovered what appeared to be tiny spiral-shaped metal objects buried in layers of earth, dated to be tens of thousands of years old. They were made of tungsten and molybdenum, metals not easily worked by primitive cultures. Some claimed they were evidence of an unknown ancient technology. Others suggested contamination or misdating. To this day, no clear consensus exists. Of course, skepticism is warranted. Most parts turn out to be nothing more than misunderstood artifacts or deliberate frauds. The famous Ica stones of Peru, carved with images of dinosaurs and surgical operations, are widely regarded as modern forgeries. The crystal skulls of Mesoamerica, once believed to be ancient relics, were likely crafted in 19th century Europe. But that doesn't mean all anomalies should be dismissed. It just means we need better tools, more open minds, and perhaps a little patience. Because even real artifacts sometimes lie hidden for centuries. The Dead Sea Scrolls, the Rosetta Stone, the buried cities of Mohenjo-Daro and Pompeii, the great libraries of ancient Alexandria, lost to fire and conquest. What might still lie buried beneath silt, jungle, or sea. There's a subtle irony in all this. The more we learn, the more we realise how much we've forgotten, and how much we never knew in the first place. Let's return to the hammer one last time. Imagine that you're holding it in your hands, cold, heavy, ancient, or maybe not. You run your fingers along the edge of the stone around it. Try to guess its age, its maker, its purpose, and then ask yourself, not what it is, but what it represents. A question, a disturbance, a reminder that even the smallest object, under the right circumstances, can bend the shape of a story. Because history isn't a straight line, it's a labyrinth, and sometimes a rusted hammer in the wrong place is all it takes to start unravelling the thread. Let's imagine you're a time traveller, not just through centuries or millennia, but through the deep grinding gears of geologic time. Your destination is a world that no longer exists, one buried not just under dirt and stone, but beneath assumptions. Your goal? To find a civilization that may have flourished 100 million years ago. But you're not looking for monuments or tools, you're looking for fingerprints in the rocks. That's where it gets difficult, because time doesn't just bury civilizations, it metabolizes them. If a species once walked this earth, talking, building, perhaps even dreaming, they may have left behind not pyramids, but geochemical signatures. Think of it like this. Every industrial activity we engage in, burning coal, smelting metal, producing plastics, leaves behind traces in the air, water, and soil. These traces settle into sediments and become layered, compressed, and preserved. And if you know how to read them, they form a kind of shadow record of our time here. So the Silurian Hypothesis asks, would we recognize such a signature from the deep past? This is where things start to blur. We know that humanity is leaving an unmistakable geological layer. We've changed the carbon cycle, the nitrogen cycle. We've distributed artificial compounds across the planet, from radioactive isotopes to microplastics. This new stratum is sometimes called the Anthropocene layer, and it's already distinguishable in ice cores, lake beds, and ocean sediments. So, could something similar be buried deeper? One of the most likely markers of a civilization, according to Schmidt and Frank, would be a carbon isotope anomaly. Burning fossil fuels releases massive amounts of carbon into the atmosphere. But not just any carbon. Fossil fuels are depleted in carbon-13, a stable isotope. So when you burn them in large quantities, the ratio of carbon-12 to carbon-13 in the atmosphere shifts, and this shift gets captured in ancient sediments and ice. Now here's the strange part. There are several periods in Earth's history when similar carbon isotope shifts occur. One is the Paleocene-Eocene thermal maximum, which we'll explore later. But another intriguing candidate is the mid-Cretaceous oceanic anoxic events, when oxygen vanished from large parts of the ocean, marine life died en masse, and thick black shales, rich in organic matter, were laid down on the seafloor. Some of these events show sudden carbon increases, rapid warming, mass extinctions. From a distance, they look a lot like what we're doing now. Historians are still debating whether these episodes were caused solely by volcanic activity, methane release, or asteroid impacts, or whether there could be other explanations. Could a civilization burning fossil fuels millions of years ago cause a similar signature? Well, that's the uncomfortable question. Of course, correlation is not causation. Nature has its own violent chemistry. Massive volcanic provinces like the Deccan Traps or the Siberian Traps have caused global disasters before, and these episodes release carbon too. But synthetic materials, artificial isotopes, that's where things get complicated. Plastics, for example, don't occur naturally. Neither do certain persistent pollutants like PCBs or Teflon derivatives. In theory, traces of these could last tens of millions of years, especially in low-oxygen environments where decomposition is slowed. So if we dug deep enough into the right sediments, we might find them. But there's a catch. The farther back you go, the more difficult it is to find undisturbed sediment. Earth has recycled itself many times over. The seafloor, where much of this chemical evidence would collect, is geologically young, constantly subducted and replaced. Land, meanwhile, erodes, and most exposed rock dates from a narrow slice of geologic time. In other words, the record is patchy, incomplete. That means a civilization that lived briefly, or existed only in certain regions, could be erased almost completely, especially if it didn't reach a global scale. Even ours might vanish that way. Now consider this odd little fact. Some ancient anomalies in the rock record still lack satisfying explanations. In certain cores from the Cretaceous, for example, scientists have found sudden enrichments in metals like vanadium, chromium, and nickel, along with dramatic shifts in oxygen levels. The leading theory? Volcanism. But the door isn't entirely closed on other possibilities, and here's where things drift from science into speculation. Imagine a civilization not unlike ours, industrial, carbon-based, technological. It burns fuel, builds cities, alters its environment. Then comes a collapse. A mass extinction follows. The biosphere shifts. Over millions of years, sediments form. Rocks compress. Plate tectonics swallow half the evidence. The rest becomes fragments, chemical hints, mineral distortions, puzzling isotopic excursions. Would we know, or would we write it off as just another natural catastrophe, filed away with volcanic winters and asteroid strikes? We already know how easy it is to overlook the strange. Take iridium, for instance. It's a rare element on Earth but abundant in asteroids. In the 1980s, scientists Lewis and Walter Alvarez found an iridium-rich layer in rocks all over the world, dated to 66 million years ago. This eventually became the smoking gun for the Chicxulub impact, the asteroid that ended the reign of the dinosaurs. But for years, that iridium layer was just a curiosity, a blip, a missing puzzle piece no one knew existed. What if there are other pieces like that, scattered in older layers? Another curious example, the black mats found across parts of North America, dating to around 12,900 years ago. These dark sediment layers are associated with abrupt climate cooling and megafauna extinctions. Some researchers believe they hold clues to a previously unrecognized impact event. Others suggest wildfires or gradual ecological collapse. But again, the record is ambiguous, and ambiguity is the curse of deep time. Here's a thought that might make you pause. Even today, scientists sometimes discover radioactive isotopes in places they shouldn't be. like the detection of technetium-99 in the oceans, a byproduct of nuclear fission, which doesn't occur naturally. It's there because of us, our reactors, our weapons, our waste. Now imagine, millions of years from now, a trace of technetium buried deep in a stable rock formation. If no other signs remained, no cities, no machines, would future geologists understand what it was? Would they wonder if someone had come before? Or would they assume it was a fluke? Because in the end, recognizing a civilization isn't about finding buildings, it's about understanding patterns, disruptions, chemical footprints, missing links, and sometimes it's about noticing that an epoch is missing. Breathe in. You just inhaled molecules that pass through the lungs of ancient beasts, over the bones of forgotten forests, across mountain ranges that no longer exist. Oxygen, the silent architect of life. We take it for granted, yet the atmosphere you just inhaled was not always this way. In fact, there was a time when the Earth's air was toxic to everything we know. And then something changed. Radically. Mysteriously. That change? We call it the Great Oxygenation Event, or GOE. It happened around 2.4 billion years ago. Before that, the atmosphere was thick with methane and carbon dioxide. But then, almost suddenly in geologic terms, oxygen appeared. Not a little, a lot. Enough to wipe out vast microbial communities, enough to rust the entire planet. But here's the twist. We don't know exactly why it happened, and more importantly, we don't know what came before. Let's look at the facts. For about 2 billion years, the Earth was dominated by simple, single-celled organisms. Most were anaerobic, meaning they didn't need oxygen to survive. Oxygen, in fact, was poisonous to them. Then, cyanobacteria, tiny photosynthetic microbes, began releasing oxygen as a byproduct. For a while, this oxygen was absorbed by dissolved iron in the oceans, forming banded iron formations, those beautiful striped rocks mined for steel today. But eventually the system saturated. The oxygen had nowhere to go. It escaped into the atmosphere, rising and rising, until the planet itself changed. Organisms that couldn't adapt died. A new evolutionary path opened. Eukaryotic cells emerged. Life became more complex. And yet, historians are still debating whether the GOE was really a slow process or a series of abrupt, perhaps even catastrophic bursts. Some geologists believe there were multiple false starts, earlier attempts at oxygenation that failed. Others think the rise in oxygen may have been driven by planetary scale changes in volcanic activity, tectonics, or even external impacts. But there's another stranger question lurking here. What if the oxygenation wasn't purely biological? What if some portion of that chemical shift came not from microbes, but from something else? Now, to be clear, this is not the mainstream view, but if we entertain the Silurian hypothesis, even cautiously, it forces us to ask uncomfortable questions. Could an industrial civilization, burning biomass, altering ecosystems, producing combustion byproducts, have contributed to one of these oxygen shifts? Could human-like behavior in a deep forgotten past have left behind what we've interpreted as a natural event? It sounds fantastical. It probably is. But then again, so did the idea of an asteroid wiping out the dinosaurs until the crater was found. Odd fact, oxygen in our atmosphere isn't stable. Without continuous renewal, mostly through photosynthesis, it would gradually decline. Over tens of millions of years it would disappear. That means any sudden oxygen spike in the distant past, without an obvious biological driver, raises questions. Was it life adapting, or life reacting to something? One anomaly worth exploring is the Lomagundi event, a massive carbon isotope excursion about 2.2 billion years ago, coinciding with a temporary rise in oxygen levels. Afterward, oxygen levels fell again for hundreds of millions of years. Some scientists refer to this period as the oxygen overshoot, but why the sudden rise followed by a crash? Was it merely an overactive bloom of microbial life, or a system in flux adjusting to a shock? Imagine an ancient civilization, biologically distinct from us but industrial in its own way, experimenting with energy. Perhaps it harnessed something similar to combustion. Perhaps it altered its atmosphere, created byproducts. It might not have been conscious of the consequences, or perhaps it was, and when it vanished, by war, collapse, or planetary rebellion, its chemical fingerprints remained. Not a building, not a fossil, just a spike, a whisper in the rock. Now let's travel forward to another mystery, the Devonian extinction, about 375 million years ago. It wasn't a single event, but a drawn-out series of ecological crises marked by declining oxygen in the oceans. Some believe it was caused by plants. Yes, plants. The first deep-rooting flora may have drawn nutrients into rivers, stimulating algal blooms that sucked oxygen from the seas. But others speculate about more exotic causes, volcanic activity, asteroid impacts, or climate feedback loops. Still, the oxygen levels fell, marine life collapsed, the biosphere reshuffled. Historians are still debating whether these oxygen shifts reflect purely natural processes or whether our understanding of Earth's systems is still too simplistic. The atmosphere is dynamic, it changes, it forgets, and in forgetting, it hides. Let's pause for another strange but real fact. We found nanodiamonds in layers of sediment dating to around 12,800 years ago, at the start of the Younger Dryas, a sudden cooling period. Some interpret these as the result of cosmic impact. Others question the dating entirely, but if true, they suggest a brief, intense burst of energy, heat, combustion, chaos. Again, the causes are debated, the evidence is murky, but the signature remains. It's not that ancient civilizations created these events. Probably they didn't, but the resemblance, the pattern, is hard to ignore. A sudden chemical change, a biosphere in crisis, a record that endures not as memory, but as mineral. Now here's where things get truly speculative. Imagine a species, not necessarily bipedal, not necessarily mammalian, that flourished 400 million years ago. It built, it burned, it cultivated, it altered its environment slowly, without understanding the consequences. It produced gases, released particulates, transformed its own climate, and then it collapsed. The Earth, indifferent, swallowed the evidence, most of it, but not all. What would remain? A carbon anomaly, a spike in sulfur, a layer of soot. Not much, but something. Here's the uncomfortable part. Our own civilization is creating that same signal now. We're increasing CO2, producing synthetic chemicals, burning forests, reshaping the nitrogen cycle with fertilizers, disrupting the oceans. And even if we vanish tomorrow, those signals will remain. Not forever, but for a long time. Perhaps long enough to confuse the next intelligent species that digs through our ruins. The truth is, the atmosphere doesn't record intent. It records chemistry. And chemistry doesn't care whether it came from a volcano or a city. So next time you hear that the Earth's oxygen levels changed long ago, without warning, without explanation, maybe take a second breath, a slower one. Because sometimes, what seems natural might not be. If the Earth has a memory, it's written in ice. Far beneath the frozen skins of Antarctica and Greenland, time rests in delicate, translucent layers. Snow falls, compresses and turns to ice, year after year, century after century, layer upon layer. And with it, a breath from the past, tiny air bubbles trapped like messages in a bottle. These are the ice cores, and they're perhaps the most honest record keepers we have. Where rocks are shuffled by tectonics and sediments can be reworked by currents, or eroded by wind, ice cores remain loyal, cold, quiet, and undisturbed. They speak softly, but clearly. They tell of carbon levels, temperature changes, atmospheric particles, and distant cataclysms. So if there were ever a way to confirm the existence of a long-lost industrial civilization, perhaps one that vanished hundreds of thousands, even millions of years ago, could the answer lie in the ice? The short answer is, only if we're lucky. The long answer, as always, is more interesting. Let's start with what we know. Ice cores have given us breathtaking insight into the past 800,000 years of Earth's atmosphere. In some places, like the Dome Sea region of Antarctica, the record stretches nearly 1 million years. Within these layers, we can track carbon dioxide, methane and nitrous oxide levels. We can pinpoint volcanic eruptions by the presence of sulfate spikes. We can identify wildfires through black carbon, and we can even distinguish the radioactive fingerprints of nuclear testing in the 20th century. That's right. Our most recent contributions, plutonium, cesium, iodine isotopes, are neatly recorded in the ice. Future civilizations, if they emerge, will have no doubt about when we are here. But ice cores are limited. They melt. They flow. They are not eternal. Most ice older than 1 million years has long since compacted or slid into the sea, which means that if a civilization like ours existed, say 5 million years ago, its breath is no longer trapped in ice. That bottle has long since shattered. Still, for the more recent stretches of time, the ice holds clues. Let's look at one particularly strange episode, the Younger Dryas, roughly 12,800 years ago. It was a time of sudden dramatic cooling, despite the planet being in a general warming trend as it emerged from the last ice age. Ice cores show an abrupt shift in temperature. Pollen records show the disappearance of warm weather plants. Megafauna die-offs accelerate. The cause? That's still debated. Some scientists point to a disruption of the Atlantic meridional overturning circulation, essentially the ocean's conveyor belt, possibly triggered by a massive freshwater influx from melting glaciers. Others suggest an extraterrestrial impact, based on evidence of nanodiamonds, melted glass, and other high-energy markers in sediments. A few fringe theories whisper something more provocative: a lost human civilization, rising in the warmth of the interglacial period, destroyed in a flood and fire. Not just myth, but memory. The basis for stories of Atlantis, perhaps. Historians are still debating whether these myths hold any historical weight, or are just cultural echoes of environmental trauma passed down and embroidered over time. From a scientific standpoint, there's no definitive evidence of advanced human civilization in that time period. But the Younger Dryas remains a mystery, and mysteries have a way of inviting difficult questions. Now imagine a civilization that lived 700,000 years ago. It burns fuel, it alters land cover, it clears forests, it raises CO2. Could those changes be recorded in the ice? Possibly. A significant sustained rise in greenhouse gases would show up. A shift in atmospheric dust from agriculture or construction might be detected. Changes in aerosol content, soot or trace metals, lead, mercury, cadmium could leave a mark. The challenge would be distinguishing them from natural causes. Volcanic eruptions can mimic industrial output. Wildfires can spike carbon levels. Methane releases can happen suddenly from thawing permafrost or submarine clathrates. So how do we tell the difference? One way is to look for patterned, sustained anomalies. For example, humanity has caused a steady increase in CO2, not a one-time spike. If you saw a gradual, multi-century rise in greenhouse gases with no clear volcanic correlate, that might suggest artificial activity. Another is to look for synthetic compounds, molecules that do not occur naturally and can only be produced through industry. Certain chlorofluorocarbons, CFCs, for example, are entirely artificial. If they were found in ancient ice, well, that would be a hard one to explain. No such compounds have yet been found in ice older than the Anthropocene. But again, the record only goes back so far. And that's the problem. Even in places like Antarctica, where conditions are ideal for preservation, the oldest ice is slowly being replaced by newer layers. The Earth is always in motion, always recycling, always covering its tracks. Ice flows, it compresses, it melts from below. So if you're looking for a civilization that predated the ice cores, you have to look elsewhere. Still, there are moments where the ice seems to whisper things it shouldn't. Tiny barium anomalies, shifts in dust composition that don't align with known volcanic events, layers unusually rich in ammonium, which might indicate biomass burning. These could be natural, yes, but they're strange, and they're real. Odd fact, during the early Holocene, some ice cores show small repeated black carbon peaks, potentially signs of fire. But the sources are unclear. They're too regular to be random, too low to suggest continent-wide wildfires, too persistent to dismiss. Some have suggested they're the result of peat fires. Others propose early human forest clearing. A few say nothing and keep drilling. Because ice doesn't speak in certainties. It breathes in silence. It waits. Let's step into imagination again. Suppose that in some forgotten age, long before the Pleistocene glaciations, a species walked the Earth with minds like ours. They lit fires. They burned forests. They developed chemical processes we'd only understand in fragments. Could any of that be found in the ice? No. The ice didn't exist yet. But the principle remains. The atmospheric chemistry they altered would have precipitated into lakes, into snow, into marine sediments. It might have shifted the global climate, tipped balances, accelerated or delayed extinction events. It would leave a trail, not in photographs or temples, but in chemistry. And if that civilization was brief, say 10,000 years long, like ours so far, It could pass beneath the radar of ice entirely, unless we were looking, and maybe we haven't been. So next time you see a photo of an ice core, remember, it's not just frozen water, it's air, ancient and true, a message from the past. And sometimes, when the world was warm and the skies turned dark, it recorded things no one meant it to. Because even silence can leave a trace. Imagine sifting through the future. Long after cities have crumbled and satellites have fallen, you reach into a layer of sediment, brushing away compacted soil and stone, and there it is. Not a bone, not a coin, but something stranger. Glossy, lightweight, fragmented. A thin blue shard shaped by something once alive. Not bone, plastic. Of all the gifts our civilization might leave behind, few are as likely to endure as plastic. Plastic is everywhere. It coats our food, binds our buildings, floats in our oceans. It rains down in microscopic flakes. It rides the wind. It even shows up in human blood and breast milk now. We are living through the Plasticine, a term some scientists use with dark humour to describe this thin synthetic moment we're carving into the crust of the Earth. And the question is, will it fossilise? Surprisingly, the answer is yes. While most plastic degrades under sunlight, oxygen and microbes in anaerobic environments, places without oxygen, like deep ocean floors or buried landfills, plastics can persist. Over thousands of years they may become mineralised, transformed into something like stone. Plasticglomerates they're called, hybrids of molten plastic and natural materials like rock, sand and shell. They're already forming on beaches in Hawaii and other parts of the world. That means future geologists, perhaps millions of years from now, could find fossilised plastic embedded in sedimentary rock, a line in the stone, a new kind of mineral, a story of us. So here's the next question. Could a past civilization have done the same? Historians are still debating whether synthetic compounds from human industry will persist long enough to enter the deep-time geologic record. But if we think plastic is forever, well, not quite. UV light breaks it down. Microbes may evolve to digest it, and over vast spans of time, tectonics, pressure, and temperature might erase the evidence. But some forms, particularly chlorinated plastics or composite materials, may persist, and if the right conditions prevail, they could fossilise like bones or shells. Now here's where the story turns inward. If another species, long before humans, had created its own version of plastic, perhaps a synthetic resin, or a polymer unknown to us, would we recognise it in the rock record? Or would it look like a strange inclusion, a dark vein, a contaminant mistaken for a quirk of geology? Let's explore something called xenoformational sedimentology, the idea that advanced civilizations might influence the structure of sediments through their activities. This includes the introduction of unusual materials, layered in ways that suggest intention, or byproducts of construction and manufacturing. The term is rarely used, but the idea lingers. Take our landfills, for example. Massive layered deposits of waste, plastics, metals, glass, batteries. These create concentrated zones of human chemistry, unnatural, dense, and geologically distinct. If these become buried and preserved, future diggers might encounter strange uniform strata of synthetic material, a layer that does not belong. But it wouldn't look like trash. It would look like mystery. Odd fact, the deepest plastic ever found was recovered from the Mariana Trench, over 10,000 metres below the surface. A single plastic bag, intact, drifting in one of the most remote places on Earth. If it settles and is buried, it might be preserved for a very long time. That one bag could outlive cities, forests, civilizations. Now imagine we go digging in ancient sediments and find a similar trace, a plastic-like material, but ancient, not one of ours. What would we think? A natural polymer? A misdated artifact? Or something we'd prefer not to consider? Here's another eerie idea. Plastics can resemble organic remains. Microplastics have been found embedded in animal tissues, mistaken for biological debris. If a similar process occurred in the deep past, if an ancient synthetic polymer integrated into organic systems, it could fossilize in ways we'd interpret incorrectly. Perhaps we've already misclassified such fossils. That's not to say we're overlooking an obvious past civilization, but rather that our classification systems are tuned to the known, the expected, the familiar. And plastic is still new to us. It's only been widely used for about 70 years, That's less than a blink in geological time, and already it defines the Anthropocene. In some lake beds and coastal regions, annual plastic deposition exceeds that of natural sediment. In core samples taken from Earth's most remote environments, Antarctica, deep oceans, mountain glaciers, plastic shows up consistently. And if that doesn't give you pause, this might. The oldest known fossilized fungus is about 715 million years old. It was preserved because of extraordinary conditions. What are the odds that plastic might do the same, preserving not just itself but other material? A film of plastic wrapping around pollen, spores or cells. A time capsule embedded in polyethylene. Historians are still debating how future beings, be they human or otherwise, might interpret the plastic layer. Will it be a curiosity, a warning, a mythology? Because let's not forget, myths often begin as misunderstandings of real events. Stories passed down from people who no longer remembered the original truth. Is it possible that we'll one day be remembered only as the bringers of plastic? That our grandest cities will fade, our languages disappear, and what remains is a synthetic shell? Let's return to the Silurian hypothesis. If plastic or its analogues were produced millions of years ago, would they survive? Would they become part of the fossil record? If they did, would we recognize them? Maybe not, especially if that earlier civilization fell early. If its creations never reached the scale of ours, if it left no plastics drifting in trenches, no landfills layered with polyethylene, just subtle inclusions in ancient rock quietly misread for decades. So next time you pick up a piece of plastic, a cup, a wrapper, a phone case, pause. You're holding one of the only materials on Earth that might outlive us, and maybe has already outlived someone else. Picture a world so warm that palm trees grow in the Arctic, a world where crocodiles swim in what is now Wyoming, and Antarctica supports lush forests. It was real. It was Earth. And it wasn't all that long ago, geologically speaking. This was the Eocene epoch, a period that began roughly 56 million years ago and lasted until about 34 million years ago. It was a time of warmth, abundance, and mystery. The kind of world that seems, on its surface, idyllic. But something was off, something subtle, yet strangely familiar, because buried within this tropical epoch is a rapid, sharp and dramatic shift, a planetary fever. The Paleocene-Eocene thermal maximum, or PTM, is one of the strangest climatic events in Earth's history. It began abruptly, within just a few thousand years, or perhaps even less. Global temperatures spiked by 5 to 8 degrees Celsius. Carbon isotopes in the sediment record shifted violently. The oceans turned acidic. The deep sea grew anoxic. Entire species vanished, while others migrated toward the poles. Sound familiar? It should. Because the PETM is the closest analogue we have to what humans are doing to the planet today. But here's the unnerving part. No one knows exactly what caused it. Volcanoes? Methane hydrate release? A comet impact? All have been proposed. None are definitive. Historians and geologists are still debating whether the trigger was natural, or something we have yet to understand. This is where the Silurian hypothesis casts a long, uneasy shadow. Could the PETM, or some aspect of it, have been the result of a past industrial civilization? Let's slow down, take a breath, and consider what we actually know. At the onset of the PETM, the Earth experienced a massive release of carbon-12, the lighter, isotope of carbon commonly found in biological materials. The spike is so abrupt and so significant that many scientists believe it came from a sudden release of methane, perhaps from thawing permafrost or destabilized methane clathrates on the ocean floor. But what if the methane wasn't entirely natural? What if the sudden influx of light carbon was the result of large-scale combustion, of agriculture, of fossil fuel use, of industry, of something eerily like us? No physical artifacts from this period suggest intelligent life. No tools, no ruins, no bones shaped by culture or language. But remember, sediment doesn't preserve such things well. What it does preserve is chemistry. And the chemistry of the PETM is peculiar. For instance, the rate of carbon release during the PETM is faster than most other natural events, excluding today, of course. That's one reason scientists study it so closely. It offers a window into what runaway greenhouse conditions might look like. Now imagine a civilization, industrial, advanced, perhaps even spacefaring, existing 56 million years ago. It burns fuel, it modifies landscapes, it extracts and refines materials, and over time it warms its own planet, perhaps inadvertently. It triggers feedback loops, glaciers vanish, methane escapes, oceans acidify, and then it collapses. Maybe it tried to reverse the process, maybe it didn't, but the damage was done, and millions of years later all that remains is a chemical anomaly, a whisper of carbon, a spike of warmth, a vanishing of deep-sea foraminifera. Odd fact, the PETM is marked not only by warming, but also by a deep-sea extinction event. Tiny marine organisms, plankton, foraminifera, suffered sudden population crashes. Their fossils disappear from certain layers. Why? Acidification, ocean stratification, possibly even temperature shock. But what if their disappearance wasn't simply environmental? What if something else had disrupted the base of the marine food web? Could chemical pollution have played a role? We'll likely never know. But here's another mystery. During the PETM, land mammals underwent sudden evolutionary shifts. In North America, early primates appear. Their fossils show up shortly after the warming begins. This explosion of mammalian diversity is usually attributed to the opening of migration corridors and the availability of new ecological niches. But some researchers have noted how synchronized the changes seem, as though ecosystems had been destabilized, creating waves of adaptation in response to a global crisis. Could it be possible that something large-scale, something technological, had altered the biosphere, even briefly? Most scientists would say no, and they're probably right. But the signatures remain strange. Historians are still debating whether the PETM was a purely natural runaway event, or if it had help from some unknown catalyst. Some believe that volcanic activity from the north, Atlantic igneous province, may have released massive amounts of carbon, but even that doesn't fully explain the speed. Let's step out of the scientific data and back into imagination. Imagine a civilization, not necessarily human, perhaps not even mammalian, that thrived in a tropical world. Its cities were built from organic polymers, resistant to decay but vulnerable to heat. Its power came from biological fermentation, from burning ancient peat, from early hydrocarbons. It expanded rapidly, then collapsed as the biosphere buckled. Its remains melted, oxidized, and were buried. And the world moved on. Over millions of years, tectonic forces erased most physical evidence. But in the chemistry of the oceans, in the pattern of extinction and migration, a scar remained. We wouldn't recognize their tools, but we might recognize their footprint. Oddly enough, scientists have recently discovered microplastics embedded in modern coral skeletons. They're being fossilized right now, which means that, under the right conditions, remnants of our synthetic age will last, not for eternity, but perhaps long enough to be misinterpreted or misunderstood. Which brings us back to the Eocene, a warm world, a shifting world, a place full of anomalies, of patterns that resemble ours, but echo from far too long ago. So the question isn't just whether a civilization caused the PETM. The question is, would we ever be able to tell? And if the answer is no, what other epochs might hide stories we'll never read? Because deep time is not a library, it's a graveyard, and some graves are very quiet. Close your eyes and travel further back than your ancestors, past the dinosaurs, beyond the early reptiles, beyond even the fish that first walked onto land. Drift back 300 million years to the Carboniferous period. You'll find yourself in a world unlike anything you've ever known, a planet of giants and oxygen, of trees that are not trees, and of ecosystems so alien they feel almost imaginary. It was a swampy, humid, green-tinted earth. Vast forests of lycophytes, giant horsetails and seed ferns blanketed the continents. Dragonflies the size of hawks skimmed the surface of still black waters. Millipedes as long as surfboards tunneled through rotting plant matter, and above it all, a sky with 35% oxygen, nearly twice today's levels. This is the period that gave us the name Carboniferous, because its legacy was carbon, buried in immense quantities. These ancient forests would, over time and pressure, become the coal seams we burn today. So here's the question. What if someone had burned them before? It sounds impossible. But if there were a time in Earth's history suited to the rise of an industrial civilization, the Carboniferous might be it. The ingredients were all there: abundant oxygen, plentiful biomass, a relatively stable climate, and rich resources. The forests provided fuel, the oxygen made fire easy, the Atmosphere was ready for change. Could a non-human species have emerged, not necessarily with steel or circuits, but with complexity, with tools, with systems? We have no fossil record of such beings, no bones with reshaped joints for gripping, no skulls with expanded cranial cavities. But fossilization is rare, especially for soft-bodied creatures, especially in environments prone to rot and erosion. Historians are still debating whether intelligence must always follow the human model. Is our path, bipedalism, opposable thumbs, language, fire, the only one? Or could a different intelligence evolve through another route? Cephalopods, for example, are wildly intelligent. They solve puzzles, use tools, and change colour to communicate, but they don't build cities, they don't write, they don't leave monuments, not yet. What if the Carboniferous had its own analogue, a species that manipulated its environment, used fire, managed energy flows, but whose artifacts were biodegradable? What if its technology was biological? Let's not forget that termites build mounds that regulate temperature, ants farm fungus, beavers reshape landscapes. Intelligence isn't always noisy, sometimes it's quiet. Now, return to the coal seams. Some are hundreds of feet thick, others stretch for hundreds of miles. These layers formed from compacted plant matter, buried and preserved without fully decomposing. But in some seams, anomalies have been found. Metallic spheres, odd inclusions, and most curiously, traces of combustion. Now, combustion can happen naturally. Lightning strikes, wildfires, even underground coal seams can catch fire and burn for years. There's a place in India where a coal fire has been smouldering since 1916. In Pennsylvania, the town of Centralia was abandoned because of an underground fire that still burns today. But there are hints, faint, debated, of ancient burning within Carboniferous seams. In Russia, geologists once reported layers of heat-altered clays and reddened sediments consistent with high-temperature exposure. In most cases, natural explanations suffice, and yet the question remains, what if? Odd fact. In 1944, in the city of Wilburton, Oklahoma, miners reportedly found an iron pot embedded in a chunk of coal. When the coal was broken open, the pot fell out, leaving an impression. Similar stories circulate: bells, nails, even tools, encased in carbon-rich stone. Most are unverified, some are outright hoaxes, but they speak to a deeper desire to find cracks in the narrative, a glimpse of something older than ourselves. Skepticism is healthy, needed, but so is wonder. Let's explore what an advanced civilization in the Carboniferous might have left behind, if it existed. Plastics? No, those wouldn't have evolved without oil refining, but other materials, biopolymers, resins, treated woods, could have lasted in anaerobic conditions. If buried quickly, some might survive, but even if nothing physical remained, the geochemical signal might. For instance, carbon isotope ratios. If a civilization had burned vast swathes of forest, we might see a temporary spike in carbon-12, indicating biological combustion. A warming trend, a sediment layer darkened with soot. Sound familiar? The Carboniferous ended with a cooling event, leading into the Permian. But before that, subtle shifts in atmospheric CO2 and ocean oxygen levels occurred. Some chalk these up to natural fluctuations, perhaps driven by tectonics or plant evolution. But what if they weren't? What if someone lit the fire first? Of course, the burden of proof is high, and rightly so. Extraordinary claims require extraordinary evidence, and so far none has surfaced that convinces the scientific community. But the absence of evidence in the Carboniferous is not as reassuring as it sounds. The planet has had hundreds of millions of years to erase, and the Carboniferous, with its marshy environments and acidic soils, was not kind to the delicate remains of life. In other words, if someone lived there, we might never know. Still, the Carboniferous remains a tantalizing candidate, a period of energy abundance, of biological complexity, of atmospheric volatility, a world ripe for experimentation. Could it be that the very fuels we burn today are not only the remnants of ancient life, but the ashes of ancient fire? It's poetic in a way. We're building our future on the buried past, and maybe, just maybe, that past includes more than plants. Maybe it includes minds. So next time you hold a lump of coal, look closer. See it not just as dead forest, but as a message a compressed blackened history, a possibility wrapped in carbon, and listen, it might be whispering something back. Imagine a city so old that not even its dust remembers where it stood. A city built long before mammals ever rose to dominance. A city made of strange materials perched on cliffs that no longer exist, swallowed by oceans that have since moved away. Now imagine trying to find that city, not from above, but from below, peering into stone layers pressed and folded and melted over hundreds of millions of years. What would remain? That's the problem with cities. They feel eternal when we're inside them. Their buildings tower, their lights blaze, their concrete feels immovable, but in geological time cities are fragile. They crumble quickly, their steel rusts, their glass shatters, their streets buckle, and once abandoned, nature takes them back faster than we like to believe. Within just 500 years, an unmaintained city is often unrecognizable. Within 10,000 years, even its foundations begin to vanish beneath vegetation, sediment and landslide. And within 1,000,000 years, nothing remains on the surface. The only hope is underground. But even that's not simple. Urban environments tend to concentrate their structures in small areas, and most are built on land, places, vulnerable to erosion, earthquakes and weather. Oceans, by contrast, preserve things better, especially when objects are buried quickly. But most cities are not built beneath the sea until they are. And that's where we find the challenge of detecting ancient civilizations. Because unless we get lucky, unless a city was buried in volcanic ash or preserved in a stable dry cave, its memory is likely gone, lost to the wind or the waves. Historians are still debating whether any current landscape features might actually be remnants of ancient artificial structures. Occasionally, a formation will catch the public's imagination. The Bimini Road, off the coast of the Bahamas, for instance. A line of large, flat stones on the seafloor, suspiciously rectangular. Some claim it's a road, others say it's a natural formation called beach rock, shaped by erosion and fracture. No consensus, just the haunting possibility. Another example is Yonaguni, a submerged rock formation off the coast of Japan. Discovered in the 1980s, it resembles a step pyramid, with right angles, terraces, columns. Some believe it's the remains of an ancient city sunk during a cataclysm. Mainstream geologists argue it's the product of jointed sandstone, eroded by currents and earthquakes. Once again, we can't be sure, but the pattern is clear. We are drawn to signs of lost architecture, especially when nature almost, but not quite, looks intentional. Now consider how few cities we could find even from the Holocene epoch, our current geological chapter. Cities like Çatalhöyük in Turkey, dating back nearly 9,000 years, are little more than mud brick outlines in the soil. Jericho, Jarmo and other early Neolithic sites require careful excavation to even recognise as human-made. And those are recent. Now imagine a city from 60 million years ago. Buried, folded, subducted. Would we even find it? Unlikely. Let's think deeper. Suppose a civilization built primarily with biodegradable materials, wood, fibre, resin. Its tools were based on ceramics or bone, its buildings made from earth, thatch and stone. What would be left? Very little. And if it had reached only a modest level of industrialization, say, small-scale metallurgy or low-temperature chemistry, it might not even leave a clear chemical signature. Its footprint would be indistinguishable from nature's own experiments. But let's suppose the opposite. Let's say this civilization reached a scale equal to ours: dense cities, power infrastructure, manufacturing, transportation, then collapsed. What happens to its cities? They decay, roads crack, skyscrapers fall, metal corrodes. Over millennia the land reclaims them, sediments build, trees grow over shattered glass. Eventually a river changes course and deposits new mud. A volcano erupts, adding ash, and the city becomes a layer. Maybe someone someday drills down and samples that layer. They find crushed stone, maybe carbon-rich, dust, a faint spike in nickel or lead. Curious, but not definitive. One more wrinkle in Earth's endlessly wrinkled skin. Let's consider an odd but real fact. In 2019, scientists discovered microtectites, tiny glass beads formed by high-temperature impacts in ancient sediment layers. These are markers of asteroid strikes, meteor airbursts, or massive explosions. Their composition is unmistakable, and yet we didn't recognize what they were for years. Now ask, what if a city had burned so intensely, through war, disaster, or self-destruction, that it produced a similar layer of fused glass and ash? Would we know the difference? It depends on context. But without bones, or buildings, or recognizable artifacts, it's hard to make the call. And the Earth is full of glass, volcanic obsidian, lightning-formed fulgurites, tektites from impacts. Even destruction leaves ambiguous traces. Here's another strange thought. What if ancient cities floated? Not literally, but metaphorically. What if a past civilization never concentrated its structures in permanent clusters? What if it was nomadic, or aquatic, or used ephemeral materials? In that case, even if it was intelligent, even if it reached a high level of complexity, it might leave no cities at all. Just footprints, just ashes, just memory. Odd fact. There are modern tribes today, like the Bajau sea nomads, who live much of their lives on the water, rarely setting foot on land. They build temporary structures, live off marine life, and pass their knowledge orally. If the Bajau were our only evidence of humanity, what would survive? Almost nothing. So when we search the distant past for cities, we're assuming those cities existed in the way we understand them. Dense, vertical, permanent. But permanence is not a universal value. A civilization might prefer mobility, decentralization, minimalism. It might be deeply integrated with its environment, more biological than mechanical, more fluid than fixed. Would we see that? Would we believe it if we did? Historians are still debating whether civilization must be defined by large structures, walls, roads, temples, or whether it can exist as a network of ideas, behaviors, and relationships invisible to the stone. Because if intelligence existed before us, and it lived lightly on the land, we may never know. It would be like a city on the wind, felt, heard, then gone. There's something eerie about symmetry. The way a snowflake grows in 6 perfect arms, the spiral of a seashell, the geometry of a honeycomb. Nature loves patterns, but then again, so do we. And sometimes, in satellite imagery or from the air, we glimpse something, just a bit too straight. A line, a circle, a grid, etched faintly into the earth. It might be nothing, a trick of erosion, or it might be a signature, a blueprint, so faint we mistake it for chance. Tonight, we drift into a quiet corner of the Silurian Hypothesis, a place where math meets mud, where gravity shapes stone and someone, long ago, might have shaped back. Let's begin with a mystery, the Nazca lines in Peru. Spanning hundreds of square kilometers, these ancient geoglyphs form animals, spirals, trapezoids, and long, straight lines that stretch across the desert. They were made by removing a thin layer of reddish stones to reveal the pale soil beneath. Some lines run for miles without deviation. Created over 2,000 years ago by the Nazca people, these massive artworks are visible only from the air, which raises questions. Were they meant for gods, for ancestors, for someone above? We don't know, but they show us that humans have long expressed ideas too big to see from the ground. Now suppose another species, millions of years ago, did the same. Would we still see it? Maybe, maybe not. Historians are still debating whether certain large-scale formations on Earth are entirely natural or subtly altered. Take the Sajama lines in Bolivia, hundreds of thousands of straight paths etched into the desert. Some intersect, some run perfectly parallel for miles, created over generations, no single creator, just paths, purposeful. Then there's Tassili Naja in the Algerian Sahara. Thousands of prehistoric cave paintings, many showing humanoid figures with round heads, bulbous limbs and something else. Abstract designs, geometric patterns, not writing but suggestive, intentional, meaningful. The problem is, nature creates patterns too. Basalt columns form hexagonal prisms, crystals grow in fractals, rivers carve dendritic shapes that mimic veins and roots. The Earth itself is geometric in a wild, untamed sort of way. But what if a structure was so large, so subtle, that we only noticed it after inventing satellite imaging? Let's talk about the band of holes in Peru. Thousands of shallow pits carved in a line up a hillside. Their purpose is unknown. Some say they were for food storage, others think ceremonial. From the ground, they're strange. From the air, they look designed. Then there's the Eye of the Sahara, the Richet structure in Mauritania, a massive circular formation over 40 kilometers wide. Visible from space, it resembles a target or a spiral. Geologists say it's a deeply eroded dome of sedimentary rock, nothing artificial, and yet it doesn't quite sit quietly. It stirs the imagination. Now, let's stretch further. Suppose a civilization once built megastructures, not skyscrapers, but continental-scale designs. Grids, mounds, canals, or even resonant chambers that aligned with magnetic fields or astronomical markers. Over millions of years, erosion would destroy most evidence. But sometimes, large-scale topographic patterns persist. Some researchers have speculated about unnatural alignments in mountain ranges or island chains. Most of these claims veer into pseudoscience, but a few are harder to ignore. Odd fact: the city of Teotihuacan in Mexico, with its avenue of the dead and massive pyramids, appears to align with the Pleiades star cluster. Similar alignments are seen in Egypt, Cambodia, and across the globe. Coincidence? Maybe. But there's something primal in us that wants to mirror the sky. What if others did the same? Let's talk about geomagnetic anomalies, regions where the Earth's magnetic field behaves strangely. Some of these spots, like the South Atlantic anomaly, are well understood. Others are less so. In certain places, instruments go haywire. Birds migrate incorrectly. Compasses twitch. Could this be natural? Of course. Could it be artificial? If so, it would require massive infrastructure, buried conductors, mineral manipulation, perhaps even global-scale energy transmission. Sound like science fiction? Maybe. But the Tesla coil once seemed like magic too, and some theoretical models, like those of Nikola Tesla or later thinkers like Buckminster Fuller, suggest the Earth could support distributed systems of wireless power, large-scale resonance, planetary harmonics. Now, imagine a civilization long before ours that discovered these principles. Instead of building computers and screens, they built resonant architectures, massive stone harmonics, towers that tune the sky, not to store data, but to store energy. Would such structures fossilize? Not likely, but the alignment might. Odd fact: recent studies of global lightning patterns suggest certain regions of the Earth discharge energy more efficiently. Could ancient beings have known this? Could they have built on these nodes? The Nazca, the builders of Göbekli Tepe, the architects of Stonehenge, all seem to understand something about placement, not just aesthetic but functional. So what happens when we find similar alignments in places millions of years old? We dismiss them, because surely no one was around to build them. But gravity doesn't lie. It pulls everything towards structure. And sometimes, in the topography of plateaus and ridges, in the angles of ancient deltas and the radial spread of volcanic shields, we see echoes, faint, uneasy. Historians are still debating whether we should re-examine satellite data for signs of intentional symmetry. So far, no credible claims, but whispers persist. Google Earth sleuths, crater counters, amateurs with time and curiosity, they search for the fingerprint, the geometry that doesn't quite belong, and maybe someday they'll find it. A perfect square, a two-straight line, a ratio in the rocks, and when they do, the question will not be, who built this? It will be, how long has it been waiting to be seen? Beneath the myths and fossilized bones, in the shadowy creases of human imagination, lurk beings we insist never existed. Reptilian humanoids, serpent kings, giants with glistening scales, the first people who vanished before history began. You might find them carved in temples, painted in caves, whispered about around campfires. Not animals, not gods, something in between. They're not part of the official fossil record, but maybe, just maybe, they should be. Tonight let's listen to the creatures that never were. Every culture on Earth has its monsters, dragons in China and Europe, Negus in India, Quetzalcoatl in Mesoamerica, serpent deities with intelligence, power and purpose. Many of these myths describe beings not simply as beasts, but as civilized, wielders of language, of knowledge, even of cities. They're often older than humankind in their respective mythologies, which raises a quiet, uncomfortable possibility. What if we're remembering something? Historians are still debating whether these shared mythologies reflect archetypes hardwired into our brains, or echoes of a collective past that predates written language. Psychologists like Carl Jung suggested the idea of a collective unconscious, that certain symbols and figures reappear across cultures because they live inside us. But others have proposed a more radical idea, that oral traditions may preserve factual memories for tens of thousands of years. It sounds implausible, and yet some Aboriginal Australian stories describe landscapes that were flooded over 10,000 years ago, stories later verified by modern geology. Likewise, indigenous legends about volcanic eruptions or glacier advances have been shown to align with real, datable events. So what if myths about intelligent non-human creatures reflect a distorted memory? A fading impression of something real, now obscured by time, metaphor and imagination. Let's consider an odd but real creature, Troodon, a small bird-like dinosaur from the late Cretaceous, large eyes, a flexible neck, and by dinosaur standards, a large brain. If any species were on an evolutionary path toward intelligence before the asteroid came, Troodon is a top candidate. In the 1980s, paleontologist Dale Russell proposed a speculative model. What if Troodon had survived and continued to evolve? He imagined a being he called the Dinosauroid, bipedal, with 3 fingers, large eyes, and a vertical posture. It looked oddly familiar. Too familiar, perhaps. Critics scoffed. The design was anthropocentric. Why would an intelligent dinosaur resemble a human? But maybe that was the point. Now suppose for a moment that evolution had already tried this once, long before us. Some researchers believe intelligence has evolved independently many times. Octopuses, crows, dolphins, elephants. It's not unique. What is rare, perhaps, is the combination of intelligence, manipulative limbs, and social communication, all the ingredients for technology. Could something like that have emerged in the Mesozoic era? The fossil record gives no definitive answer. Bones degrade, brains decay, and as we've seen, even a full civilization could be erased over millions of years. But we do know that bipedal, grasping-limbed reptiles existed, and some paleontologists believe dinosaurs were more complex than we once imagined, more colourful, more social, possibly even warm-blooded. Now imagine if a lineage developed writing, not paper scrolls but maybe marks in soft clay or tree bark, gone, eaten, decomposed, or they used pigments on walls since crumbled or subducted, and their stories, carried forward not in stone but in memory, myth, legend, cryptids. Let's talk about reptilian humanoids, the staple of conspiracy theories and science fiction. From the ancient serpent kings of Sumeria to the Naga of Southeast Asia to the shape-shifting reptilian beings in modern folklore, these figures persist. They are often portrayed as subterranean, ancient, watching us. Why reptiles? Because they endure, because they belong to the deep past, because their fossilized ancestors ruled Earth for 160 million years, because in the long shadow of evolutionary time mammals are newcomers. Odd fact, the tuatara, a lizard-like reptile in New Zealand, is the only surviving member of an ancient reptilian order that once flourished alongside dinosaurs. It hasn't changed much in over 200 million years, a living fossil. What if others once walked upright? We have no fossil evidence for bipedal intelligent reptiles, but absence of evidence isn't evidence of absence, especially when time erases. So why don't we see traces of their civilization? Well, maybe we do. Maybe we dismiss them. Stone tools attributed to early humans, could they be misidentified? Carvings with reptilian figures, are they symbolic or biographical? Consider the Ubaid figurines from Mesopotamia. Dated to around 7,000 years ago, they depict humanoid figures with elongated heads and lizard-like faces. Scholars call them religious artifacts, but their style is startling. Too stylized or too specific? Historians are still debating whether these figurines are part of a symbolic system, or if they reflect something more concrete. A memory, a lineage, a mythology with roots deeper than we know. Let's return to science. If an intelligent reptilian species had emerged and gone extinct, we would expect certain evolutionary clues, transition fossils, skeletal adaptations, braincase expansion. We don't have those, but then again, we barely have complete fossils of Homo naledi, a human ancestor from just 300,000 years ago. and that was in a cave. If intelligent life had evolved earlier, deeper in time, in a remote ecosystem, or in conditions hostile to fossilization, its record might be thinner still. There's also the matter of bias. We're trained to recognize signs of human intelligence: tools, buildings, symbolic art. But an alien intelligence might signal itself differently, through ecosystem engineering, behavioral complexity, or even biochemical alteration of its environment. Could some of the ancient carbon spikes we've discussed be biological signals, not just geological ones? Could the PETM, or other warming events, be partially linked to industrial-scale combustion by something else? It's speculative, highly so. But science begins with questions, and sometimes the things we dismiss as fantasy are simply out of place in our current framework. So next time you see a dragon carved into an ancient wall, or read a story about the serpent who taught humanity fire, or dream of creatures with amber eyes and clawed hands, pause and ask, what are we remembering? The past isn't only buried in rocks, it's carried in blood, curled up in the double helix of DNA, a fossil you can't hold in your hand, but one that follows you everywhere. If something lived before us, something intelligent, ancient, long erased by time, could its fingerprints still linger inside us? It's a haunting question, because while stone forgets, genetics remembers. Our genome is a vast archive, not a dusty library, but a living replicating scroll written in nucleotides. Every cell in your body carries traces of not only your ancestors, but of ancient viruses, dead cousins, and failed experiments of evolution. The human genome is not clean. It's noisy, fragmented, full of stutters, repetitions, and strange insertions that no longer serve a clear purpose. Some of these fragments come from horizontal gene transfer, where genetic material jumps between species, often via viruses or symbiotic relationships. It's not how we were taught evolution in school, but it's real, and it's messy. Now let's ask the unspeakable. What if some of these inserts, these scraps and glitches, are more than just biological noise? What if they're traces of something else? Historians are still debating the role of ancient viral insertions in shaping human evolution. Some segments of our DNA are clear relics of retroviruses, genetic hitchhikers from millions of years ago. Others, like the HARs, human accelerated regions, are sequences that evolved unusually fast. No one knows exactly why. They seem to govern brain development, cognition, and even social behavior. Could they be natural? Of course, probably. But every now and then something doesn't quite add up. One particularly odd case is the FOXP2 gene. Found in many animals, it governs aspects of vocalization. But in humans, it mutated rapidly and became essential for speech. When researchers compared our FOXP2 to that of chimpanzees, they found two unique mutations. These changes appear to have swept through the human population around 100,000 years ago, suggesting a strong selective advantage. But how did it change so fast? Why then? Was it just chance? Or something more deliberate? We're not saying ancient engineers tampered with early humans. That's the stuff of science fiction. But if an earlier species, intelligent, perhaps even technologically advanced, existed before us, could it have interacted with our ancestors, altered ecosystems, introduced organisms or viruses that left genomic ripples? Even now we find DNA in ourselves that doesn't entirely belong. Consider the ghost lineages. As scientists study ancient DNA from Neanderthals, Denisovans, and early Homo sapiens, they occasionally find fragments that don't match any known hominin group. These sequences come from unknown archaic humans, species we haven't yet identified. We call them ghosts because they appear only in genetic form, with no fossil trail to accompany them. Could some ghost lineages be even stranger, more distant, maybe not even human? A speculative thought. If a prior civilization engineered life, perhaps through genetic manipulation or selective breeding, its modifications could still be present in modern organisms, especially if those organisms were allowed to interbreed with the natural population. Their legacy wouldn't be buildings, it would be bloodlines. Odd fact, banana plants, as we eat them today, are sterile. They are the product of artificial selection. If humanity vanished, future civilizations might wonder, why does this plant exist if it cannot reproduce on its own? The same could be asked of domesticated animals. Cows, for instance, have traits selected not for survival, but for utility. Now imagine finding such a creature in the fossil record, clearly domesticated, but with no domesticator. Would we recognize that as evidence, or would we chalk it up to evolutionary anomaly? There are already animals in the fossil record that baffle scientists. One example is Tullimonstrum, or the Tully monster, a soft-bodied, alien-looking creature from the Carboniferous. It defies easy classification. Its body plan is so bizarre that no one knows where it fits in the tree of life. Was it a vertebrate, an invertebrate, a mistake? And then there's Hallucigenia, from the Cambrian explosion, an animal so strange scientists initially reconstructed it upside down, spines on the bottom, tentacles on top. It took decades to figure out which end was the head. If we struggle to understand natural organisms, how would we fare with engineered ones? Let's move beyond animals. What about plants? What if an ancient civilization modified flora, not for aesthetics, but for food, fuel, or fibre? Some changes, like polyploidy, extra sets of chromosomes, can occur naturally but are also induced artificially. Today we use radiation and chemicals to mutate plants deliberately. If someone did this millions of years ago, the result might persist as an unexplained anomaly, an unusually robust fern, or a grain that appears suddenly in the fossil record. Historians are still debating the origins of agriculture. The Neolithic revolution is often framed as a sudden leap, a mystery in itself. But what if we weren't the first to shape nature to our will? Could someone else have tried, failed, and vanished, leaving only altered seeds behind? And what of symbiosis? Some theories suggest that mitochondria, the powerhouses of our cells, were once independent organisms that merged with early life. A merger so successful it changed biology forever. Could other symbiotic relationships, more complex, more engineered, have once existed? What if we carry not just the genetic fingerprints of ancient viruses and bacteria, but of a civilization, a people who modified us, or our ancestors, without ever imagining their legacy would one day awaken? Let's not forget junk DNA. Vast portions of our genome serve no known function. They may be remnants of ancient viruses, or they may be placeholders, code whose purpose we no longer understand. There's a term in genetics, endogenous retrovirus. It refers to viral sequences embedded in our genome. Most are inert, but a few are active, shaping development, immunity, even brain function. If a past species manipulated biology at the genomic level, we might find its signature not in fossils but in functions, in the shape of our minds, the tone of our voices, the way we dream. And maybe, just maybe, that's why certain myths persist, why we dream of gods and monsters, why we tell stories of teachers from the stars, why we look at the sky and feel nostalgia. Perhaps it's not memory, perhaps it's inheritance. Some ideas begin as stories, not textbooks, not white papers, just whispers in a dark room, or the flicker of a thought wrapped in starlight. What if we weren't the first? What if someone came before? What if the myths and monsters, the ancient anomalies and strange alignments, all point not to fantasy, but to something real? Science, of course, is cautious. It demands evidence. It distrusts poetry. But sometimes, even in the quiet halls of academia, a thought slips past the gatekeepers. That thought became known as the Silurian Hypothesis. It started in 2018 when two highly respected scientists, Gavin A. Schmidt, a climate scientist and director of NASA's Goddard Institute for Space Studies, and Adam Frank, an astrophysicist and science communicator, published a paper in the International Journal of Astrobiology with an eyebrow-raising title, The Silurian Hypothesis. Would it be possible to detect an industrial civilization in the geological record? It wasn't satire. It was a serious, methodical exploration of a simple, disquieting question. If an industrial civilization had existed on Earth millions of years ago, would we know? The name came from science fiction, specifically the Doctor Who universe. In it, the Silurians were an ancient race of intelligent reptiles who lived on Earth long before humans, went into hibernation to survive a planetary catastrophe, and awoke millions of years later to find mammals had taken their place. Schmidt and Frank borrowed the name with a wink, but their premise was grounded in real science. They examined Earth's known geochemical record and asked what kind of anthropogenic fingerprints, human-like, effects, could persist over tens of millions of years. What they found was sobering. Many of the markers we associate with human civilization, cities, plastics, tools, are unlikely to last that long. but chemical signals might. The paper identified several key features that a past civilization might leave: a sharp, abrupt carbon isotope excursion, indicating large-scale fossil fuel combustion, increased sedimentation rates, possibly from deforestation, agriculture, or urban development, synthetic molecules, compounds like plastics or pesticides that don't occur naturally, metals and rare earth elements in unusual concentrations from mining or manufacturing, a mass extinction driven by rapid climate change. And here's the unsettling part. The geological record already contains episodes that look like this: the Paleocene-Eocene thermal maximum, the Triassic-Jurassic boundary, the Devonian extinctions, all marked by abrupt warming, carbon spikes, disrupted ecosystems. Historians and geologists are still debating whether these events were caused by natural feedback loops, like methane release or volcanic activity, or something else. The Silurian hypothesis doesn't argue that any specific event was caused by an ancient civilization. It simply asks whether, if it had happened, we would even recognize it. The answer, not confidently. The authors concluded that unless a past civilization lasted long enough to alter the planet globally and consistently, much like we're doing now, its traces could easily be lost, buried, or mistaken for natural events. And even then, ambiguity would remain. This brings us to a strange and humbling realization. We may not be the first, and we may not be remembered either, because science fiction, when taken seriously, becomes a tool. It stretches the imagination into spaces science won't yet enter. It allows us to test the boundaries of our assumptions, and sometimes those boundaries turn out to be weaker than we thought. Odd fact: the idea that the Earth might once have supported previous civilizations isn't limited to fiction. It's whispered in Plato's Atlantis. It echoes in the Hindu concept of yugas, vast cosmic cycles in which worlds are created, destroyed, and reborn. It hides in the Mayan calendars, in the Egyptian king lists, in the Sumerian records of kings who ruled for tens of thousands of years. Science often dismisses these as myth, but myth too has its place. It preserves questions when answers are unavailable. Take the famous short story by Arthur C. Clarke, The 9 Billion Names of God. In it, monks use a computer to catalogue every possible name of God. When the task is complete, the stars begin to go out. It's fiction, but it makes a point. Completing a pattern can have consequences, and in the case of the Silurian hypothesis, the pattern is this: civilization rises, alters the planet, collapses, disappears, leaves traces, is misunderstood. Then, another rises, and the cycle continues. Let's take a moment to revisit the idea of technological evolution. In modern science fiction, we often assume progress leads to machines, to spaceflight, to metal and fire. But what if a past civilization followed a different path? What if it developed biotech instead of metallurgy, organic computation rather than silicon, structures grown, not built? Such a civilization might not leave metal. It might leave modified DNA, altered ecosystems, genetically engineered symbiosis that looks indistinguishable from nature. Or it might be spiritual, communal, a distributed consciousness housed in trees or fungi or neural coral networks. Their civilization could have breathed through the forests and sung through the oceans, and when they passed, they left behind nothing but quiet. Would we notice? Probably not. We barely recognize how much we don't know. In a way, the Silurian hypothesis is less about the past and more about the present. It reminds us that civilization is fragile, that memory fades, that nature doesn't archive, and that we too could become a mystery. Our own layer, already forming, might be mistaken for a volcano, a sudden bloom, or the residue of an unknown comet. Our satellites will fall, our skyscrapers will turn to dust, our plastic will fossilize, perhaps briefly, and then dissolve. Unless someone is looking, really looking, they may never know we were here, just as we may never know who came before. Turn off the lights and listen, not to machines, not to rocks or signals, but to stories. The oldest archive humanity possesses is not stored in vaults or databases, but in the soft murmur of voices around firelight. Stories passed from parent to child, generation to generation, long before the first word was ever written. What if some of those stories are true? Not literally, not in every detail. But what if myth is where the memory of an earlier world survives? distorted, simplified, symbolic, yet rooted in something real? Across the planet, we find remarkably consistent legends of lost civilizations, great floods, forgotten ages, and non-human teachers who came before. They speak of Atlantis, Lemuria, Mu, Hyperborea, the antediluvian kings, the Sumerian Apkallu, the Egyptian Zep Tepi, the first time. They speak of destruction, usually by water or fire. They speak of secrets buried in stone. Coincidence? Maybe. But when enough myths rhyme across cultures separated by oceans and epochs, it forces us to look closer. Let's begin with Plato, who first introduced the tale of Atlantis around 360 BCE. According to his dialogues Timaeus and Critias, Atlantis was a powerful maritime empire located beyond the Pillars of Hercules, modern Gibraltar. It was highly advanced, morally decadent, and ultimately destroyed in a single day and night of catastrophic floods and earthquakes. Plato claimed this story came from Egyptian priests who told it to Solon, who passed it down. He insisted it was history, not allegory. Historians are still debating whether Plato invented Atlantis as a parable or preserved an echo of something much older. No archaeological site matches his description exactly, but that hasn't stopped speculation. From Santorini to Doggerland, from the Azores to Antarctica, Atlantis is everywhere and nowhere, and it isn't alone. In Hindu cosmology, time is divided into yugas, vast cycles in which civilizations rise and fall. The Satya Yuga, or Golden Age, is followed by progressively darker ages. We are said to be in the Kali Yuga, the most degenerate and short-lived. The Mahabharata and Ramayana, ancient Indian epics, describe advanced cities, airborne chariots called vimanas, and weapons resembling nuclear explosions. Metaphor, probably, but strikingly precise. In Mesopotamian tradition, the Sumerian king list includes rulers who reigned for thousands of years before a great flood. Afterward, lifespans shortened dramatically. The Epic of Gilgamesh, older than the Bible, speaks of antediluvian wisdom and the knowledge of immortality lost to mankind. And then there's the Bible itself. Genesis describes Nephilim, giants, sons of God, and mysterious figures who lived before the flood. Noah's story, too, parallels flood myths in dozens of cultures, from the Ojibwe in North America to the Babylonians, from the Maoris to the Yoruba. Floods, loss, and rebirth repeat. But here's the strange part. Many of these myths include architectural details: stone cities swallowed by sea, temples aligned with stars, subterranean chambers, hidden records. They speak of knowledge that came from before. In Egypt, for instance, the concept of Zep Tepi, the first time, refers to an age when the gods walked among humans. Not metaphorical deities, but rulers who taught writing, agriculture, astronomy. The Great Sphinx, some argue, predates dynastic Egypt by thousands of years, based on signs of water erosion. This theory, proposed by geologist Robert Schoch, remains controversial, but it suggests the possibility of a lost chapter. Then there's Göbekli Tepe, a site in modern Turkey, dated to 11,600 years ago. Massive T-shaped pillars, arranged in circles with carvings of animals and symbols. It predates Stonehenge and the pyramids by millennia. Built by people with no known agriculture or writing system. Its purpose? Unknown. Some scholars now speculate that Göbekli Tepe is a memory anchor, a monument meant to preserve knowledge from a lost world, perhaps from survivors of a catastrophe, a flood. Odd fact, the end of the last ice age, around 12,800 years ago, coincides with the Younger Dryas event, an abrupt cooling thought by some to be caused by a cosmic impact. Meltwater pulses flooded coastlines. Sea levels rose over 100 meters in just a few thousand years. Entire coastal civilizations, if they existed, would have been erased, but their stories might remain. Historians are still debating whether oral traditions can truly preserve accurate memories for thousands of years. But examples exist. Aboriginal Australian stories of sea level rise, long dismissed as myth, were later confirmed by geological data. In Alaska, Inuit stories about glacial surges aligned with ice core evidence. In India, legends of sunken temples near Dwarka were confirmed by underwater ruins. So perhaps myths aren't false. Perhaps they are compression algorithms, data shrunk into story, passed down through unreliable narrators. With each generation, details mutate, metaphors replace mechanics, gods replace engineers, but the core survives, a great city, a collapse, a flood, a warning. Some believe remnants of such lost knowledge exist in places like the Vatican archives, or deep in the Tibetan monasteries, or encoded in sacred geometry. Others look to untranslatable texts like the Voynich manuscript, or undeciphered scripts like Rongorongo or the Indus Valley seals. They search for fragments, but maybe the best place to look is where we least expect, in story, in the symbols of the tarot, in the lyrics of lullabies, in the epics told under stars. Myth is the shallowest grave, always close to the surface, and while science demands proof, myth demands belief. The Silurian hypothesis doesn't need myths to be valid. It stands on geology, on logic. But if we open the door just a little wider, let the metaphors breathe, then maybe, just maybe, we can see myth as data, as the emotional sediment of an earlier world. So next time you hear a tale of a golden age, of beings who came before, of knowledge lost beneath waves, don't dismiss it too quickly. It might be a ghost, or it might be a memory. Now, tilt your gaze upward, away from Earth, toward the cold, rust-red planet drifting just beyond our grasp. Mars, dead, quiet, and battered. A world of canyons wider than continents, volcanoes tall enough to scrape the edge of space, and riverbeds long since dried into silence. It's lifeless, they say. But it wasn't always. What does Mars have to do with the Silurian hypothesis? Everything. Because if we want to understand whether civilizations could have risen and fallen on Earth without a trace, then we must also consider the same possibility elsewhere, especially on a planet so similar yet so heartbreakingly different. Mars was once warm. It had a thick atmosphere. It had rivers, lakes, and possibly even oceans. Scientists have detected ancient shorelines, mineral deposits that only form in liquid water, and sedimentary structures resembling deltas. In short, it was habitable for millions, maybe hundreds of millions of years. So the question becomes, was it ever inhabited? Or more provocatively, did it host a civilization? Most mainstream scientists balk at the idea. There's no clear evidence, no buildings, no technology, no bones. But what if Mars experienced its own cycle? What if it had a biological window, a brief blossoming, and then nothing? A collapse, a transformation, a burial beneath dust. Here's where things get interesting. Historians, geologists, and astrobiologists are still debating the nature of certain anomalies on Mars. Take the infamous Face on Mars, an image taken by Viking 1 in 1976, showing what appeared to be a humanoid face on the surface in the Cydonia region. Later, higher resolution images showed it to be a mesa, just a trick of light and shadow. Case closed? Maybe. But others noticed that nearby structures in Cydonia appeared patterned, aligned, angular. Some claimed pyramidal shapes, complex geometry, even ratios reminiscent of Earth's ancient monuments. Independent researchers proposed an entire city grid, partially buried by erosion. Of course, erosion on Mars works differently. There's no rain, no rivers now. But wind, thermal expansion, and dust storms still sculpt the surface over eons. Could structures, if they ever existed, have been degraded into unrecognizability? Possibly. Odd fact, Mars has no plate tectonics. That means its surface, unlike Earth's, doesn't get recycled. If something were built there 1 billion years ago, it wouldn't be subducted or melted down. It would still be there, just weathered, crumbled, erased by time and sand. That makes Mars paradoxically a better time capsule than Earth. Let's revisit Earth for a moment. Our oldest surviving human structures, like Göbekli Tepe or the pyramids of Giza, are around 10,000 to 5,000 years old. That's nothing. Blink, and it's gone. Now imagine trying to find a structure that's 100 million years old. Not possible, not here. But on Mars, there's a chance. NASA's Perseverance and Curiosity rovers roam the Martian surface, not in search of cities, but biosignatures, chemical traces of past microbial life, carbon isotopes, sediment layering, possible stromatolites, the quiet, humble building blocks of biology. But suppose those rovers stumbled upon something odd, a geometric object, a buried regular structure, a carved angle not easily explained by wind or volcanic activity. What would happen? Would it be dismissed, classified, or quietly studied and shelved? There's precedent. The moon rocks returned by Apollo missions revealed strange ratios of certain isotopes, unlike any known terrestrial formation. Some fringe theorists argue this suggests manipulation, though mainstream geology has other explanations. Still, the temptation to interpret anomalies as natural is strong, safer, simpler. Now back to Mars. If we found, say, a rectangular slab buried under regolith, or a repeating grid in the polar layers, or a cavern filled with hexagonal patterns, what would we do? Call it pareidolia or history? There's another reason Mars matters to the Silurian hypothesis, because it allows for the export of civilization. If an earlier intelligent species arose on Earth, millions of years ago, it might have expanded. Left traces not only on our planet but on others. Perhaps not starships and colonies, but probes, outposts, symbols. Even now we humans are sending devices to Mars, rovers, orbiters. Soon, perhaps, human footprints. In a few thousand years, if our species vanishes, those machines will still be there. Silent, rusted, but recognizable. And they may last longer than anything on Earth. Could Mars host their probes? Let's talk about Phobos, one of Mars' moons. It's a tiny, irregular satellite with an unusual orbit, hollow-sounding in radar tests, with grooves along its surface that some interpret as unnatural. In 1989, Soviet scientist Iosif Samuilovich Shklovsky speculated it might be a captured artificial satellite. The idea was dismissed. But even now, Phobos retains its mystery. Even stranger, a monolith-like structure sits on its surface. It's likely a boulder, a natural extrusion. But it stands alone, sharp against the plane, and it doesn't look like it belongs, which of course might mean nothing. But that's always the way with deep-time mysteries. Most of the time, it means nothing, until it doesn't. Historians are still debating whether intelligent life requires a set of predictable environmental conditions, liquid water, stable climate, moderate radiation, or whether it might arise in stranger places. Underground oceans, subsurface biospheres, deep planetary mantles. If so, life could be hiding within Mars, not just on it. There may be reservoirs of briny water beneath its surface, liquid pockets warmed by geothermal heat. And if microbial life can survive there, perhaps more complex forms once did. Perhaps they left behind not structures, but chemical signals. Signals we haven't yet recognized, or haven't been allowed to. The Silurian hypothesis forces us to look at Earth with new eyes, but it also invites us to examine the solar system with old questions. Because the real issue isn't whether there's evidence on Mars, the issue is, are we open to finding it, or do we only see what we expect? So next time you stare at a picture of Mars, dusty, red, empty, squint a little. Let your eyes relax. Let your imagination wander, because mirrors don't always show the present. Sometimes they reflect what was, and what we've forgotten. Now let the silence fall, like dust over old cities. Let it settle in the corners of abandoned towers, over empty highways overtaken by vines, across rooms that once held warmth and breath. Imagine our world, without us. No war, no fire, just absence. It happens quietly at first. The lights go out, the satellites drift, the sea returns to places it once ruled, the wind moves through glassless windows, and the earth, patient and unconcerned, begins the slow work of erasing us. It sounds like science fiction, but it's not. We know, because we've run the simulations. We've watched what happens when cities are abandoned. Pripyat, near Chernobyl, swallowed by forest. Hashima Island in Japan, left to crumble into the sea. Detroit neighborhoods overrun with weeds, temples hidden in jungle, stone buried under time. Our own future is a preview of someone else's past. And here is the darkest, most poetic twist of the Silurian hypothesis. We may be the very ghosts we fear, not in the literal sense, not time travelers or reincarnated souls, but examples. We are what a short-lived industrial civilization looks like, a brief flare, a geologic smudge, a story that vanishes before it can be finished. Historians are still debating whether the Anthropocene, our current age, deserves its own place on the geologic timescale, but the evidence is mounting. Our layer is distinct. A thin ribbon of plutonium isotopes from nuclear testing, a scattering of microplastics, a bloom of fertilizer-induced sedimentation, a pulse of carbon-12, and if we disappear tomorrow, that layer will persist. For how long? Perhaps millions of years in the right places. Ocean sediments, peat bogs, permafrost, deep lakes, but everywhere else, erosion will take its toll, rain will eat at concrete, steel will oxidize, data will decay. We talk about leaving a legacy, but legacy is fragile. Take a memory stick, bury it, come back in 10,000 years. Even if you recognize it, you likely won't be able to read it. The data will have corrupted, the format will be meaningless, and that's if you understand what you're looking at. Now apply that same idea to us. If something intelligent arose 10 million years from now, after we're gone, after our bones and buildings are dust, they might find the Anthropocene layer. They'd see the plastic, the chemical shift, the radioactive markers, and they'd wonder, just as we do now. They might find our fossils too, but not many. Fossilization is rare, and most of us are cremated, buried shallowly, or lost at sea. Even today, with 8 billion humans alive, our physical remains will account for a vanishingly small percentage of future fossils. We are not permanent. Odd fact, it's been estimated that just 1 out of every billion organisms becomes fossilized. Of those, only a fraction are ever discovered. Most fossils that exist lie buried, unnoticed, forgotten. So, if we found no trace of a previous civilization, what does that really prove? Nothing. It might mean there was none, or it might mean we haven't looked in the right way, or that we never will. This is where the Silurian hypothesis becomes not just a scientific question, but a philosophical mirror. We want to know if someone came before, but perhaps we ask because we sense something else, that we are not permanent, that we too will be forgotten, that this, our buildings, our machines, our satellites, is a song the earth will hum for a while and then let go. It's humbling, it's terrifying, and it's beautiful. Because if we are the ghosts of tomorrow, then perhaps our purpose is not to be remembered, but to notice, to look at the planet and ask, are we alone? Not just in space, but in time. Are we the first, or just the latest? And when we vanish, will someone ask the same? There's an irony here. We build monuments to outlast us, pyramids, towers, data centers. We dream of archives on the moon, of Mars colonies, of eternal remembrance. But the Earth is patient. It doesn't remember in the way we do. It doesn't care about our monuments. It remembers through chemistry, through isotopes, through extinction patterns, through traces. And so, our skyscrapers will fall, our names will fade, but the carbon shift will stay, the plutonium will stay, the plastics for a while will stay, not as stories, but as symptoms. Perhaps the next species will find them, perhaps not. Perhaps they'll interpret them as natural, or perhaps they'll wonder, who were they? What were they trying to say? Maybe they'll find one of our landfills, a compacted, buried layer of synthetic waste, and mistake it for a strange sedimentary deposit. They'll puzzle over its composition, the way it suddenly appears, the tiny uniform shapes of bottle caps and microbeads. They'll call it the synthetic stratum. They'll debate its origin for centuries, just as we now debate the carbon spikes and black shales of the distant past, and they'll never know it was us. Unless we tell them, unless we leave a message designed to last, carved in diamond, encased in rock, orbiting a stable star outside tectonic reach. Or maybe that's already been done. Maybe someone left a message for us, and we just haven't learned to read it yet. If you wanted to speak across the abyss of time, not years, not centuries, but millions of years, how would you do it? Not with books. Paper burns. Pages rot. Not with metal. It rusts. It bends. It vanishes. Not with data. Not with film. Not with digital media. They require machines to read them, power to run them, languages to interpret them, and every one of those things fades, one by one, bit by bit, until the message becomes nothing more than a blank whisper. To speak to deep time, you need stone, but not just any stone. You'd need something durable, stable, geologically anchored, resistant to erosion, tectonics, and weather. Something placed in a spot unlikely to be submerged, buried, or melted. And perhaps more important, a symbol that doesn't require translation. This is what some thinkers call the problem of the long now. It's not just about sending a message, it's about sending one that will still be there and still be understood when the sky has changed and continents have drifted. It's a puzzle that nuclear waste engineers grapple with. How do you warn people, or post-humans, 10,000 years from now not to dig here? Skull icons? Language? None are reliable. The solution might be aesthetic. Not a warning, but a mystery. A shape so unnatural, so precise, so out of place in the natural world that it forces recognition. A signal, not of danger, but of design. And if such a signal existed, could we see it? Historians are still debating whether certain ancient megalithic sites, like Baalbek in Lebanon or the Osirian at Abydos in Egypt, were meant to preserve knowledge, or were simply foundations and tombs. But their scale, precision, and enigmatic placement raise questions. Some stones at Baalbek's Temple of Jupiter weigh over 800 tons, far beyond the lifting capability of known ancient technology. At the Osirian, deep beneath modern ruins, water runs silently past perfectly fitted blocks, cut with strange smoothness and seemingly advanced engineering. Odd fact, the largest known cut stone block in human history, over 600 tons, lies half buried in a quarry at Baalbek. We don't know why it was left there. We don't know how it was moved, or if it ever was. If you didn't know who built it, when or why, what would you assume? A natural hill, a sacred site, or something older? Now extend that puzzle backwards, not 2,000 years, not 10,000, but 500 million years, during the Cambrian explosion, long before trees, birds, or bones. Could anything survive that long? Maybe. Deep within the Canadian Shield, rocks have remained undisturbed for over 3 billion years. In the heart of Australia's Pilbara Craton, the oldest fossils on Earth, stromatolites, tell us that some things endure. If you were to build a message into bedrock, compress it, bury it, preserve it with intent, it might still be there, waiting. But how would we know where to look? Some theorists propose that any civilization with foresight would create alignment markers, structures or symbols tied to celestial configurations, star maps, carved in stone, that point to a specific sky. Why? Because the stars move predictably over tens of thousands of years. It's a cosmic clock. If you found a pattern of dots, and those dots matched no known modern sky, you might run the simulation backwards until they aligned. And that alignment would give you a date. It would say, we were here, then. A few researchers have pointed to the Pleiades, a star cluster present in mythologies from Japan to the Maya, as a possible anchor. Others suggest that precessional cycles, the slow wobble of Earth's axis, could be used as a long-range signature. So far, we've found no confirmed message of this kind. But then again, we might not know what we're looking for. Let's return briefly to deep sea cores. Sediments at the bottom of the ocean accumulate slowly, one layer at a time. They're dark, cold, and quiet, ideal for preservation. And yet, we drill only a few centimeters at a time. We examine the chemical signatures, the isotopes, but rarely do we think to look for patterns, geometry, code. What if the message isn't carved in cliffs but layered in mud? Imagine an ancient civilization creating a long-lasting signature, not with monuments, but with engineered microbes, designed to survive in the ocean, multiplying slowly, incorporating themselves into the sedimentary record over millennia. Their structure would leave a pattern, regular isotopic ratios, molecular complexity, perhaps even information stored in DNA. Because as it turns out, DNA is surprisingly durable in the right conditions. We've extracted it from bones over 100,000 years old. Theoretically, under the right circumstances, it could last millions. Could a message be encoded in the genome of some long-forgotten bacterium? And could we, one day, decode it? Some researchers now speak of DNA computing, using strands of nucleotides not just as biology, but as storage. Vast amounts of data, written into microscopic chains, resilient to electromagnetic pulses, compact beyond anything silicon can offer. If someone before us discovered that, then perhaps the planet itself contains an archive, not in stone, but in cells, waiting, or already speaking, in a language we no longer understand. We often search for radio waves, signals from the stars, but maybe the true language of advanced intelligence isn't built on light or sound. Maybe it's written in the earth, in the rocks, in the mud, in the double helix. Maybe the message isn't, we were here. Maybe it's simply, you are next. Now the question lingers. It does not scream. It doesn't demand your attention. It just waits. Because if there was once another world, another intelligence, another language spoken by those who vanished before us, then where are they now? The absence isn't just silence, it's deafening. We don't see their tools. We don't hold their books. We don't hear their words echo through time, but perhaps they didn't leave things behind. Perhaps they left absence. Let's consider a haunting possibility. What if their most lasting creation was not a monument, but a mistake? What if they too reached a threshold of energy, of consumption, of atmospheric imbalance, and in reaching it they triggered their own undoing, not through war or flame, but through a climate cascade? What if, in their pursuit of progress, they sowed the seeds of a long forgetting? You've heard this before, haven't you? It's the song of our own time, the warming oceans, the acidified seas, the tipping points, uncertain and looming. Some scholars believe that if an earlier industrial species ever existed, the chemical fingerprints of its collapse would look uncannily like our own. Carbon spikes, mass extinctions, a layer of disruption in the Earth's sedimentary record. They wouldn't have needed to last long, just a few centuries, perhaps even decades, to leave a permanent mark, to start an irreversible process. And then, nothing. Historians are still debating whether civilizations must inevitably end in collapse, or whether some can endure, evolve, and harmonize. But in geological time, collapse is common. Stability is rare. Most complex systems, whether ecosystems or empires, eventually fall into entropy. Odd fact, Earth has experienced at least 5 mass extinction events. The worst, known as the Permian-Triassic extinction, or the Great Dying, wiped out over 90% of all marine species. Its cause is still unclear. Volcanism, methane release, perhaps both. But some have wondered, could that have been triggered? By what? By whom? It's speculation, yes. But the Silurian hypothesis isn't about proving a prior civilization existed. It's about testing how well we would see it if one had. And the answer, unsettlingly, is not very well. If the data were subtle, if the signs were small, if the footprint was shallow, we might never know. And in that uncertainty, we glimpse our own reflection. So let's ask, what if we are not just the first or the next, but the only? What if the silence isn't evidence of others, but of emptiness? What if Earth is not a revolving stage for repeated drama, but a rare, fragile singularity? Then everything we do, every risk, every choice, becomes the whole story. There is no rehearsal, no second act. And what if the silence is intentional? A warning? A natural filter, stripping away the reckless, the short-lived, the unwise? Because there's another theory in the background of all this, the Great Filter. It's the idea that somewhere along the path from chemistry to civilization to spacefaring wisdom, most species fail. They destroy themselves before they escape their planet, or worse, before they even know they're in danger. Maybe intelligence isn't the apex, maybe it's the test, and if so, then this moment, right now, this very century, could be the bottleneck, the narrowing tunnel through which few, if any, pass. We don't know what lies beyond, but if the past holds echoes, if the rocks carry secrets, if the myths preserve truth in disguise, then we're not just scientists, we are archaeologists of possibility. We are listening to the silence beneath our feet, hoping for a whisper, because buried somewhere in this planet's layered skin may be the trace of another story, one told without words, one half erased, one that failed to reach the stars. And now it's our turn. Will we be found? Will we be understood? Or will we vanish, like smoke through leaves, leaving only a wisp of warmth behind? There's still time. Maybe that's what the Silurians, if they ever existed, are telling us. Not we were here, but don't do what we did. Or perhaps nothing at all. Because the silence in the end is not malevolent. It is simply the Earth, dreaming again. And maybe we are part of the dream. And now, dear listener, the story winds down. You've wandered through eons tonight, drifted between stars and stones, touched the edge of memory and myth, whether or not there was a world before ours, a secret epoch erased by time. You've walked in the shadows of the question, and that's what matters. Not the answer, but the asking. Let the thought settle like dust on a forgotten shelf. Let it glow faintly, like a candle left in a room long abandoned. You don't need to hold on to it. Just let it exist, quietly, beside your dreaming mind. Tonight, Earth is still spinning. The wind still hums. Somewhere beneath layers of sand or seabed, messages, real or imagined, wait to be found. Perhaps we're already writing our own. Don't fear the silence. It is not an end. It is a pause, a breath before another story begins. And now, as you lie still, breathing slow, safe beneath your blanket of stars, let the images grow softer. The cities vanish, the oceans calm, the skies darken to velvet. You've travelled far, through history, through hypothesis, through time, and it's okay not to remember everything. That's how dreams work. So let go now. Let the earth sleep. Let yourself sleep. And if you dream of ancient ruins, of strange machines half buried in sand, or of cities that sing beneath the sea, know that you are not alone. The past is with you. The future is listening. Good night.